Hi, it's time for more calculus. Yeah, woo, let's do this thing. More particle motion. Woo! Okay, if you're still cheering, you can take a moment. You can do that. You can pause this and continue to cheer, but I'm going to get started. So here it says we're going to do 146 through 148. Can you believe that that's where we are already? So exciting. Okay, so 146 through 148. And it says right now more on particle motion. So continuing where we left off. And then this is finding net and total distance. So a little bit different today than what we've been doing in the past, but still a lot of the same ideas that are there. And it says right now that this graph is velocity. So I want to write that really big down here, measured in meters per second. So I'm going to make sure I make note of that, of a particle moving along the x-axis. Anytime you see that a particle is moving along the x-axis, it just means that we have a very boring particle and it only moves right or left. So it can only go this way, no other movement, and that's it. Here it says what value of t does the particle have no acceleration? So let's think about what no acceleration means. So no acceleration. Remember, acceleration is the derivative of velocity. So I'm going to write that in there. So then whoever is looking at this, if it's me or if it's an AP reader or whatever, knows that you know that connection. So v prime of t is equal to a of t. And that's also a good reminder just for us. No acceleration. So what about the times when acceleration is equal to 0? That means v prime of t would be equal to 0. V prime of t is the slope of v of t. And if I look up here, a of t is equal to 0. The slope is 0. From here to here. So on this interval, 3 to 6, because that's where the slope of the tangent is 0. And you might be saying, yeah, but what about those sharp turns? What's happening there? At 1, at 3, at 6, and at 8, it looks like, that is the place where the derivative does not exist. There's a sharp turn in the graph of the velocity. So I'm going to say, and a of t does not exist. So I'm covering both bases, but I really know like my stuff here. So an a of t does not exist at t equals 1, t equals 3, t equals 6, and t equals 8. And I'm going to say as v of t has sharp turns at those values of t. So here I'm justifying this. I said v prime of t is equal to a of t. I said a of t equals 0. I'm justifying my answer. Like, this is all the justification. This was my interval, so I answered the question about the acceleration, and then I'm good. The next one, you can see I already started filling this in. It says express acceleration as a piecewise defined function from 0 to 10. And so the first thing that you need to do is just set up what are the breaks in your piecewise function. If I look up here on my graph, I'll move it down slowly. I'm trying to get better about not getting in your way when you're writing. I'm breaking this up from 0 to 1. I can see that's where the first line is happening. From 1 to 3, the second one. From 3 to 6, 6 to 8, and then 8 to 10. That's what those breaks, those changes are happening in the graph of v of t. That's why this is changing also. If I were just writing a piecewise function for v of t, I would write the equation of the line in each of those intervals. But this is not, it's a of t. That is the derivative of velocity. And so at all those locations at 1, 3, 6, and 8, I can see right here, I didn't put equal to in any of those places. And the reason why is because acceleration is not defined. There are sharp turns in the graph of velocity at those locations, so its slope is not going to be defined at 1, 3, 6, or 8. Now, a of t is just the slope of velocity. So what I want you to do is from 0 to 1, I want you to say, what is the slope from 0 to 1? It's like rise over run, y2 minus y1. From 0 to 1, I'm going up 3, right 1. My slope is just 3, and then comma on those places. A of t from 1 to 3, this would be going down 3, 6 over 2. So this one's going to be -3. What's the slope from 3 to 6? We already set it up above that a of t was equal to 0 at those locations. The slope of tangent is 0. I put commas in between there. From 6 to 8, what's the slope? Well, I'd be going up 3 to here, 3 to here, so that'd be 6. And then I'm going over 2, so +3 again. 8 to 10, I'd be rising a -3, running 2, so -3 over 2. It's hard to see. That says -3 over 2. And so a of t is just the slope of v of t at particular moments. But this, because on these intervals, I'm just seeing straight lines, you can just find the slope. The average rate of change is equal to the instantaneous rate of change also at those places. Next question. So both of these are reviews. So if you want to try them and then come back and check your answer, you could do that now. If you're going with me, just stay with me. So a particle is moving to the right, and I'm not even looking at the graph yet. I'm just going to say a particle moves to the right, and I'm justifying before I even start. Particle moves right when, and I know a particle is moving to the right when velocity is greater than 0. And down here I'm going to say a particle moves left, so I'm justifying this one when velocity is less than 0. And now we can say when it occurs. So I'm going to say which occurs on the interval or in this case intervals, because I'm looking up above, which occurs on the interval. Just setting this up. If I look up above and I think when is velocity greater than 0, I'm just looking for the places above the x-axis. So positive is above the x-axis, negative is below. So I'm looking from 0 to 2 and then 7 to 10. 0 to 2, 7 to 10. I'm just writing and. And the other one, when v of t is less than 0, it's only from 2 to 7. That's the places where v of t is below the x-axis. So 2 to 7. Okay, average acceleration. This is an average rate of change of velocity. Average rate of change is just the slope of a secant line. If I know from 1 to 8, I'd be finding the velocity at 8 minus the velocity at 1. And just to check before I even keep going further, just to make sure this will be acceleration, velocity is measured in this problem in meters per second. It's given at the top of the page. Meters per second, 8 minus 1 would be seconds. Meters per second. Yeah, I'm good. This is going to be acceleration. V of 8 minus V of 1. V of 8 is 3. V of 1 is also 3. 3 minus 3 is 0. 0 divided by 7 is still 0. You still need to make sure that you put units. This would be meters per second was in the numerator, because that was what velocity was given as. This 7 down here would be seconds. And what that just means is the acceleration, the average acceleration from 1 to 8 is 0, meaning not speeding up, not slowing down, not doing any, and be careful about the way we say this, but velocity over that whole time is remaining fairly constant, even though we can see the velocity changes a lot. But we've got some of the times where velocity is positive balancing out the times where velocity is negative. Okay, so just one more time. Here's the entire page, so if you want to check any work, you can. Okay, let's move on to the next one. This I started filling things in, so hopefully I won't get into your way as much. Write as much as you need to for the definition of net distance and total distance, but you can also just think about it too. So I'm never going to make you repeat this. I just want you to understand what they are. So net distance is just if you take your final position minus your initial position. So when we talk about particles, they are very, very boring. So let's say a particle started here and then moved right 5 spaces and then move back, so then they stop there, and then after the 5 spaces they move back this way. Let's say this whole distance, that red distance, is 6. So they move 5 to the right and 6 to the left. If you move 5 to the right and 6 to the left, net distance would just be 1. And the reason is it's going to be, so I'm at position 5 over here. If I started at position 0 and I came back 6, I'd be like, think about a number line at like -1. This distance from here to here is only 1. If we're talking about total distance and I go 5 places to the right, 6 places to the left, total distance is the actual path. So you would be going 11 places, like 11 units, whatever that is. So net distance is going to be just the initial position and your final position. You subtract them in order to find your distance. The total distance is going to be, you measure up all the distances traveled. So it matters when you travel to the right. It matters when you travel to the left. You add those distances together. But let's say a particle is moving in the same direction the entire time. So I start at position 0 and I travel and I go right and right and right and right and I end up at position 10. What's the net distance? 10, because we went 10 to the right. That's where I'm ending. What is the total distance? 10, because that's all I've moved. So if you're moving in the entire direction the entire time, the net distance will equal the total distance. But only if a particle is moving in the same direction the entire amount of time. So if this, then the net distance equals the total distance. So not all the time, but in those circumstances. So in the next part I wrote down for you, just so I could move my hands out of the way and you could write it. To find the net distance, you take your final position minus your initial position. Well, what's that mean? If we're given a position function, then we can say what's sometimes called S of t, sometimes x of t, sometimes p of t. I just named this one S of t, and I set on an interval from a to b, so it's some time interval from a to b. I take S of b minus S of a, and you're done pretty quickly. If you're doing the total distance, it takes a little bit more work. For total distance, I said you had to add up all the distance traveled, and so these particles are very boring. They're either moving to the right or moving to the left, and so what you need to do is figure out when is a particle moving to the right and when is a particle moving to the left. When velocity is 0, that's when that change occurs. If velocity is positive, that's when a particle is moving to the left. If velocity is negative, oh, I said that wrong. Whew, that was scary. If a velocity is positive, that's when a particle is moving to the right. There we go. If a velocity is negative, that's when a particle is moving to the left. And so we need to account for those possible changes. So we add up the distance traveled. This is the basic explanation. But how we do that is we set velocity equal to 0. We make a chart, and then we see, is there a change in position? So let's say from A to C, and so I'm talking about some time interval A to C and then C to B. I know that's a little weird because I didn't go in alphabetical order, but I just did that just because I just chose the next letter. Let's say this is negative from A to C, the velocity is negative. That means the particle is moving to the left. If velocity is positive, I know the particle is moving to the right. What I need to do is take whatever this interval is, and just like you did net distance at the top, or you did final minus initial, you do that within each interval. So S of C minus S of A. Do the same thing over here. If you're moving to the left, this number, whatever you get, this distance is going to be negative, and we don't want distance to be negative. So whatever your answer is for your distance moving, you need to make sure that that's in absolute values. If you're moving to the right, it wouldn't matter because you would still end up with something positive, but this just saves you every time, because then you wouldn't actually have to figure out when is the particle moving left and right. You would just need to know when velocity is 0, and then you could move to the step next and just say the absolute value of the change in position of that first interval plus the absolute value of the change in the position for the second interval. Okay, here I've got find a position of a particle given by this function. I've got P of t is equal to 2t, or 2t cubed minus 6t squared minus 8t. P of t measures in centimeters. So P of t is the position, and it's asking me to find the net and total distance. The net is going to be the easier one. The net distance is just going to be P of, what is this, 1.5 to 4 seconds? P of 4 minus P of 1.5. And then you're just substituting it up here. So P of 4, P of 1.5. If I do that, I'm going to go to what old me had to say about this. P of 4, if you're substituting into this function up here, you will get 64. P of 1.5, and if you don't believe me, you can surely do this, but P of 1.5 is going to be 5.25. And if I subtract them, I get 58.75, and then you make sure that you put units. So in this one, if position was given in centimeters, my net distance is also in centimeters. To do the total distance, a little bit harder, because I need to see, does the position change, like do I change directions at any time? So does the particle change directions at any time? Direction is determined by the sign of velocity. So I need to see, well, where is that possible change happening? So what I want to do is indicate that I know what velocity is. So I want to say P prime of t is equal to V of t. So I know, hey, the derivative of position is velocity. That would be 6t squared minus 12t plus 8. And I need to see, is there any place where this derivative, V of t, equals 0? So the derivative of P of t, which is V of t. Is there any place where I get 0? Because this could potentially tell me where this function is positive and where it's negative. I'm going to factor something out here. I can factor out a 2. Can I do a 2? Sure I can. 3t squared minus 4t plus 6. This 3t squared minus 4t plus 6, and the 2 wouldn't really matter because you could just divide by 2 and you get 0. Nothing, that's not going to affect this. But here, this actually, like, we could spend some time trying to figure out where this is equal to 0, but if you try to factor it and you're like, okay, two numbers multiply to get 18, add to get negative 4, you're not going to be able to get that. If I try this on my calculator, just so you can be convinced, I would have 3t squared minus 4t, so minus 4x plus 6. I'm only talking about the interval from 1.5 to 4, so I'm going to change my window so that it looks like, well, I'm going to see, yeah, I'm out of the thing. 1.5 to 4, I'm going to change this so it's just like 0 to 5 that I can see on the x's. I don't know, negative 10 to 10, I don't know what this will look like yet. I can see over that entire interval, so even if you would do the quadratic formula, there's going to be no place where I actually get a 0 for that function. This is a parabola and it's always above the x-axis, which means that velocity is always positive. And you could say on the interval 1.5 to 4. And so I'm already accounting for that. And so what I can do then is I can be like, well, if I know the particle is always moving to the right, I know that about the position. The particle is moving always to the right. Then this equals net distance, but also total distance. And I might drop some knowledge here and say as particle is always moving right. Or you could say moving the same direction, then you don't even have to say anything else on this. But, oh, there we go. Okay, let's do a little more. One more page. That's probably where you're chanting at home, and then your parents were like, shh, be quiet. And you're like, one more page. I know. Okay, so we've got this one. We have the position of a particle is given by this function. And so we have this function right here, where P of t is measured in feet, find the net and total distance from 0.5 minutes to 1.5. One of these is going to be a lot easier than the other. Which one's the easier one? Net distance. Net distance is always just going to be P of 1.5 minus P of 0.5. So if I do this, I'm going to look back to previous me to see if I have this work already done. Yes, I did. Okay, so P of 1.5 minus P of 0.5. And if you put this in your calculator, and this can just be in the regular, like just substituting in these numbers 1.5 and 0.5, you should get 8.0855369. And I'm using more than 3 places after the decimal because this is not my final answer yet. So I need that degree of accuracy until I get to the very end where I can do only 3 places after the decimal. Minus P of 0.5, you will get negative 1.2817. And that's okay, because this would be, my position to start out with would be like my position at 1.5, or I guess ending is going to be positive. That's fine. Negative over here, we're good. Minus negative, we're still saying I'm adding up those distances. Think about it on a number line, for instance, and I get 9.367 feet. Total distance is the one that I said is a little bit harder. So total distance, we have to figure out, does this particle change directions? And the way that we do that is we have to find velocity. So to do total distance, so just labeling my work here a little bit so I know and I can follow this work through, P prime of t is what my velocity is. So my velocity, e to the 2t, the derivative of e to the anything, e is e to the anything times the derivative of the anything, minus 8. And then if I want to set this equal to 0, which I do, I have 2e to the 2t minus 8. If you want to at this point, you can find your calculator right now and find out when this 0 happens. If I want to keep going, which I kind of do, and just solve this just for good practice, finding something with an e, I can divide both sides by 4, or by 2, and get 4 is equal to e to the 2t. And then if I take the natural log of both sides, the natural log of 4 equals the natural log of e to the 2t. Natural log and e go away, so I get 2t is equal to the natural log of 4. And I did this not because this is a nice answer, because this is just the natural log of 4 divided by 2, where I can say 1/2 the natural log of 4. I'm not doing this because, oh, sorry, I'm focusing this, so I'm not giving you an eye test. There we go. Seemed a little out of focus. It's not because this gives me a much nicer answer. It's just because if you did the natural log of 4 divided by 2, so the natural log of 4, and you take that and you divide it by 2, this is just really long. The 0.6931471,806, that's a long thing to keep writing, so I just chose to write it as the natural log of 4 divided by 2. But you do you. Or you could say 1/2 the natural log of 4. Then I'm going to make a chart. 0.693 is in that interval from 0.5 to 1.5. So yes, I need to consider it. I'm going to start at 0.5 to, I'm going to say 1/2 the natural log of 4. But you could have used that decimal. 1/2 the natural log of 4. I know that velocity is 0. And then from 1/2 natural log of 4, maybe it's not easier to write this way, you decide, to the end of my interval, which is 1.5. I don't actually need to know right and left here, so I don't have to substitute in these values. I just did this so I could get this clear in my mind, and I could say, okay, well, what's my next step from here? I need to find the distance from here to here, and so what I'm going to do is P of whatever 1/2 the natural log of 4 is, or you could say 0.6931471,806, that's fine, minus P of 0.5, And I don't care whether this is moving right or left as long as I put an absolute value around this. And then I do the same thing over here. And I say P of 1.5 because you're taking the position from the end of the interval minus the position at the beginning of whatever your interval is. When you're doing this, make sure that you're going back up to the position function and substituting in these values. You should get, I'm looking at Means work, so you can do this on your own and then compare and make sure we have the right thing, or you can follow along with my work. It's up to you. This one I ended up getting negative 1.545177 minus a negative 1.2817. I've got to write smaller. Over here, this was 8.0855369. I'm trying not to block this. Minus a negative 1.545177. Ah, that's going off the side of the page. And here, just so if you missed anything, you could get, this would be the absolute value of negative 0.263459 plus the absolute value of 9.63071. So we end up seeing this was the distance left because it was negative, this was right, but that's okay. And then here, if I add up the absolute value of both of these, the total distance is 9.894 feet. So just not much more than the other one, but still slightly different. Okay, one more example. 4 is one more page. Now you're chanting and you're like losing a little steam. You're like, one more example, that's what I want. I know this is a lot. I appreciate you more than you know. Okay, in this one, the position of a particle is given by P of t is equal to t plus 2 sine of t, where P of t is measured in feet. Ooh, did I put feet? Yeah, I did put in feet in the last one. Phew, I thought I forgot units. Find the net and total distance. Okay, one of these is either easier than the other. To find the net distance, you are finding the final position. So P of 5 pi over 4 minus the initial P of pi over 6. What is this? P of 5 pi over 4 minus P, and you can use your calculator on this one, so it shouldn't be too scary that these are trig values and whatever. You can use your calculator on this one, totally fine. But you should get that this is 2.512777255 for P of 5 pi over 4 minus 1.523598776. And then as the net distance you should get when you subtract 0.989 feet. And that was for net distance. For total distance, you got to do a little bit more work. So sometimes it's easy to get stuck in the process of these, so let's think about it. What is finding the total distance? You find the distance the particle has moved to the left, find the distance the particle has moved to the right, and you have to add those distances together. So what I want to do is find total distance. So I need to know when is the particle moving to the right or to the left, or could be moving to the right or left, like what are those intervals? You want to set velocity equal to 0. Well, the only thing that was given was position. So I need to take the derivative of position. The derivative of t is 1. The derivative of 2 sine of t is 2 cosine of t. And then you set that equal to 0, which you could do by hand if you wanted. You are using your calculator, so there's no reason you have to. If you want, again, for good practice, you have to think about where does cosine of a value equal negative 1/2. And so if I'm thinking about this, I'm thinking of a triangle, and you can see this, I've got a triangle. Well, you can't see it because I have another paper here before, but the way that I think about this is I'm using a triangle in some way, and I've got Yeah, square root of 3 and 2 and 1. And I think about what kind of triangle that is, and that would be if I had pi over 6 up here and pi over 3 down here in this angle. And I think all the places where I would have adjacent over a hypotenuse. So I'm thinking of pi over 3 as my reference angle, but I want something negative. So cosine is going to be positive at pi over 3. But right here in this quadrant and in this quadrant, it's not. So if I go here, I would have t equals 2 pi over 3. And then I could keep going, and at cosine is over in this quadrant, it would be 4 pi over 3. But if I do 4 pi over 3, and this is 5 pi over 4, 4 pi over 3 is 4.188. 5 pi over 4 is actually 3.926. So, sorry, it's really hard to see. There we go. So 4 pi over 3 actually isn't in that interval, so you don't use that. So the only place where I change positions is at 2 pi over 3. I'm writing this chart only to help me get my thoughts organized, that I'm going to be saying, okay, well, I've got something happening at 2 pi over 3, because I know velocity is 0 there. So my intervals would be from pi over 6 to 2 pi over 3, and then 2 pi over 3 to 5 pi over 4. I need to find the change in position here and here. So I'm going to say position at 2 pi over 3 minus position at pi over 6. I do the same thing over here. Position at 5 pi over 4 minus position at 2 pi over 3. Again, you can use a calculator for this one. I'm taking the absolute value just because I don't know whether I'm moving right or left, and I don't want the negative to affect my answer. If you say 2 pi over 3, there's some work here. This would be 3.82644,591 minus 1.523,598,776. This is a lot, but people are going to think you are so smart, which is very exciting. 2.302847,134. This is that first change in position, and then the particle changes direction. P of 5 pi over 4, 2.512777255, minus the position at 2 pi over 3. 2 pi over 3 is 3.8264459. I just want to show you these things in case you get stuck somewhere, so then you know where to look back. I'm hoping you're not actually listening to every part of this, because you probably fell asleep by now. This is negative 1.313668655. And so if I've got this positive and this negative, but I'm taking the absolute value, so I'm adding them together, total distance should be 3.616. 3 places after the decimal. It's the accuracy right now. Feet. That was a lot. Great job sticking with me. Thank you so much. I think you're awesome. Please let me know if you need anything. Don't get stuck in the crazy numbers here. Make sure that you understand net distance is just the final position minus the initial. For total distance, you have to set the velocity equal to 0 and then find those intervals. So pretty much you're finding the net distance of those little intervals and then taking the absolute value of those distances, adding them together to find total distance. Thanks so much for being great. Bye!